Okay, so now the capstone on chapter 5, solving quadratic equations. The whole point of learning all these factoring techniques was to solve quadratic equations. And it comes down to this one concept. It's called the zero factor property. If you can set an equation equal to 0 and factor it to where two things are multiplied together, it uses the idea that if two numbers multiply to 0, one of them has to be 0. So once you factor it, if it's in an equation form, you can set either of your factors equal to 0 and solve to find out what your potential x values are. So solve the following equations that have already been factored. X plus 5 times x minus 2 equals 0. You take each factor and you set it equal to 0. So x plus 5 equals 0 or x minus 2 equals 0. That means subtracting 5 to the other side. X is negative 5. Adding 2, x is 2. So these are our solutions that can make this equation true. Because if I plug in negative 5, I get 0 here, and 0 times anything is 0. If I plug in 2, the second parentheses is 0, so it's anything times 0, still 0. If you have a common factor, you can also set it equal to 0. So this represents t being factored out. That is also something you can set equal to 0, as long as there's a variable there. If there's no variable there, you don't need to set a number equal to 0. So that's just t equals 0 as a solution. But here we subtract 5, 6t equals negative 5. So t is negative 5/6. So this is what it would look like if you have a common factor or if you have a number in front of your variable. Now, unlike that one, let's look at number 4. You don't need to set 2 equal to 0, but if you do, it's okay. When is 2 equal to 0? Never, so this doesn't produce any solutions. X plus 2 equals 0. 4x plus 9 equals 0. So x is, again, negative 2. 4x equals negative 9, so x is negative 9/4. One last thing to note, as I leave 2 and I'll leave 6 for you, if you get the same solution twice, here you get x minus 9 equals 0 and x minus 9 equals 0. X equals 9 or x equals 9. You really only need it once if it shows up multiple times. So you can just put x equals 9. That goes for, because this is x minus 9 squared. If it's squared, you only need to put it once. Okay, so let's practice some where we have to do the factoring. So again, we're going to use our factoring techniques, and then we will solve once we're done. And the first thing you have to do is make sure it's equal to 0, so you need to move everything to one side. And then you will factor using the GCF and your factoring techniques and set every factor equal to 0 that has a variable. And solutions can be placed in braces separated by commas. So, and if you have something like x equals 4 and x equals 3, you can put it in braces 3, 4, depending on what your homework may have you do. Okay, y squared plus 3y plus 2 equals 0. It's already equal to 0, so we're just going to factor. This is y plus 2 times y plus 1. Take each of your factors, set it equal to 0. So y is negative 2, or y is negative 1. So we can write that as negative 2, negative 1 in braces, if we want. I'm going to leave 2 for you to do. Remember to set it equal to 0. I think and 3 and 4 would be a good idea. I want to leave plenty of these for you to practice or ask about in class as necessary or by email. So let's look at number 5. First things first, set it equal to 0, so we need to move the 21x. So we've got 3x squared minus 21x equals 0. Now we factor. These have a common factor of 3x, leaving x minus 7. Set every factor equal to 0. So we can set 3x equal to 0 if we want. X minus 7 equal to 0. This is x equals 0 or x equals 7. Which means I can put my solutions again in braces, 0 or 7. Similar to number 6. This is 36b squared plus 60b plus 25 when I move it, because it has to be equal to 0. Now this is kind of a hard one, because 36 times 25 is 900. So we're looking for factors of 900 that multiply, or that add to 60. Thankfully, 30 and 30 multiply to 900, so I can separate my middle term and factor by grouping. So I will get 36b squared and 30b share a 6b and leave 6b plus 5. 30 and b and 25 share a 5 and leave a 6b plus 5. So my two factors are 6b plus 5 and another 6b plus 5. This is actually a perfect square. You may not notice looking at it. Equals 0. So that means either 6b plus 5 equals 0 or 6b plus 5 equals 0. We only need one of them. So b is negative 5, 6. And I don't need both. So I can put this by itself in braces if I want. Now, these at least give you an idea. Sometimes they force you to do other things first before you can even get there. So let's talk about number 1. G times g minus 7 equals negative 10. I would like this to be equal to 0, but I can't have this factored form equal to negative 10 and do anything with it. I'm going to have to distribute my g to get g squared minus 7g equals negative 10 and move my 10 over. G squared minus 7g plus 10 equals 0 before I factor. So from here I can factor, get g minus 5, g minus 2, set them each equal to 0. So my solutions are going to be g equals 5 here and g equals 2 here. So that's the solutions 2 and 5. So sometimes you have to multiply first. 2 is similar to that. Sometimes there's more to evaluate. For example, look at number 4, we'll start it, and I'll leave the rest to you. If there's a common factor, you factor it out. X times x squared plus x minus 20. And from here, you still need to factor this. And you can have potentially more than 2 answers, possibly 3. In this case, you'll have 3 different answers. Now this last set is kind of tricky. I would suggest just multiplying it out. There's this idea here. If you multiply this out, which most of you will do, and get it all on one side, you can do that. You can also just subtract everything to one side. Now what do I mean by that? 3x times x plus 1 times minus 2x plus 3 times x plus 1 equals 0. If you're clever, you can look at this and say, wait a minute. These share a factor of x plus 1, and I can factor it out. X plus 1 times 3x, that's the outsides that are left, minus 2x plus 3. Namely, this is x plus 1. 3x minus 2x is x minus a positive 3, so that's minus 3. So this is actually x plus 1 times x minus 3 equals 0. So we get x plus 1 equals 0, x minus 3 equals 0. So x is negative 1, or x is 3, or in our solution set, it's negative 1 and 3.